Okay, let's solve our first system of three equations with three variables. Now here they are. Now this 1 and 2 and 3 doesn't mean multiply or anything like that. This just means this is equation 1, equation 2, and equation 3, so we can refer to them in this way if we like. So I've given some guidance here on how we're going to do this one. Let's choose equations 1 and 2 and eliminate the z. And you can see why I did that. Look how easy it's going to be to eliminate the z from those two. All we have to do is add those two equations together, and since the z's have opposite coefficients, -1 and +1, the z will go away. Next, we're going to choose equations 1 and 3 and do the same thing. Now, I just want to make a couple of notes. You could choose any two of the equations and eliminate any of the three variables here. All you need to do for the second one is choose two different equations. In other words, don't make it identically 1 and 2. You could make it 1 and 3 or 2 and 3. And then you need to eliminate exactly the same variable. So this z needs to match that z. They could have been x, they could have been y, or they could both be z. And then you solve the equations, two equations that have two variables. In this case, it'll be x and y because we eliminated z. We'll do that just like we did in the previous section. And finally, once you know x and y, you can go back to any one of these equations and plug in our known values for x and y and figure out what z is. All right, well, let's proceed here. We're first going to use 1 and 2, and all we need to do is add them together. So equation 1 is x plus 4y minus z equals 20. I'm going to write equation 2 underneath it. 3x plus 2y plus z equals 8. And we're going to note that the z is going to be eliminated when we add these two together. So adding, we get 4x plus 6y equals 28. And we don't have to, but we could call this equation, well, we've got 1 through 3. We could call that equation 4 if we wanted to. All right, next, we need to choose 1 and 3 and eliminate z. Well, let's look at 1 and 3. What am I going to do to eliminate z? If I just add 1 and 3, the equations, I'm not going to eliminate the z. So I have two choices. I have a -1z, but a +2z here. One is I could divide equation 3 by 2, and it would give me a 1z here. And that would work, but I might get a fraction here and there, which is perfectly fine. You'll get the correct answer. I think instead I'm going to double equation number 2 to get a -2z right here. So I'm going to say 2, I'm going to write down 2 times 1. That means 2 times, that's equation number 1. 2 times equation number 1 is going to be 2x plus 8y minus 2z equals 40. So all I did is doubled all the coefficients, all the numbers in equation 1. So 2x plus 8y minus 2z equals 40. And then equation number 3, I'm just going to write right underneath it. Equation 3. So I'll get 2x minus 3y plus 2z equals -16. As we expected, the z's are just going to drop out. They're going to cancel out when we add, cancel out to 0. So here we get 4x plus 5y equals what? 24. So if we wanted to, we could call that new equation, equation 5. So we're going to use equation 4 and 5 to solve for x and y, because we have two equations and two unknowns, just like we did in the previous section. So let's see. If I can't just add them together, well, but I could subtract them, couldn't I? Or I could multiply one of them by -1. Maybe I'll do that work right up here. I will say negative 1 times equation number 4, which would be negative 4x minus 6y equals negative 28. And underneath it, I'm going to write equation 5, which has 4x plus 5y equals 24. And that will eliminate the x's when I add them together. So I will get, let's see, negative 6y plus 5y. Negative y equals negative 4. So multiplying both sides by a negative 1 gives us y equals 4. All right, that's part of our answer. Now let's plug in to either equation 4 or equation 5, any equation that just has x and y in it. Let's go up here to this one. 4x is equation 1. Equation 4, I mean. 4x plus 6 times y, which is 4, is equal to 28. Okay, so 4x plus 24 equals 28. Subtract 24 from both sides, and we get 4x equals 4. So x is equal to 1. So we're almost done. We just need z now. X is a 1, y is a 4. Let's figure out what z is. Let me write down equation 1 here. Equation 1 would say x, which is 1, plus 4 times y, which is 4, minus z equals 20. So I just rewrote equation number 1, but I replaced the known value of x, which is 1, and y, which is 4. 4 times 4 minus z equals 20. So this should give us z. That's a 16, and that's 1 is a 17, minus z equals 20. So if I subtract 17 from both sides, I get negative z equals 3, which means positive z is equal to negative 3. Let me make sure we did that correctly. X is a 1 and y is a 4. So 1 plus 16 minus z is equal to 20. And that means 17 minus z is 20. Negative z is equal to 3. Yeah, z is a negative 3. So we believe the answer is x equals 1, y equals 4, z equals negative 3. 1, 4, negative 3. But I want to double check that. We used equation 1 to figure out that z was a negative 3. I want to plug all three of these numbers into equations 2 and 3 just to be safe, just to make sure we didn't make any arithmetic mistakes. So equation 2 would be 3 times 1 plus 2 times 4 minus 3 equals 8. Let's make sure that's true. 3 plus 8 minus 3. Yeah, 3 and minus 3 cancel out, and it gives us 8. So we're good there. Let's go ahead and check the last one as well, just to verify. 2 times 1 minus 3 times 4 plus 2 times negative 3 equals negative 16. Let's double check that one. 2 minus 12, and this is minus 6. Minus 12 and minus 6 give you minus 18. Plus 2 gives you minus 16. So we are correct. So this is the solution. And I may have mentioned this once or twice before, but I'm going to mention it again. This equation is a plane in 3 space. It could be like the xy plane, or it could be any plane. This is another plane, and this is another plane. So this is like three planes that are meeting at a point. And you could think of that planes as being like the floor and two walls that meet. Well, the point on the floor, right in the corner where both of those walls meet the floor, that would be this. Okay, so three planes meeting at this one single point.